section 9.1. When we do this, when we graph data where we have some X number related to some Y number, by the way, which is the independent and dependent variable for temperature versus number of customers for ice cream? Independent is the temperature, right? And then the number of customers is dependent because it depends on what the temperature is. So when we plot this, this is actual data. So when we plot it, that is called a scatter plot. When we plot those points. And we're looking for a pattern, which may or may not be linear, but of course we know because it's in this section that it's linear. So scatter plot is a graph of a set of data points. If Y tends to increase as X increases, then we say it has a positive correlation. And if Y tends to decrease as X increases, then we have a negative correlation. They can both still be linear. So negative would be like as time goes by, as you're driving, the gallons of gas left in your car as you're driving. So you can model this with a line. I'm not sure mine will stick, but when we draw that line, it's called the line of best fit. There's a couple of ways of saying it, line of best fit, or you can call it the regression line. So let's write both of them in. Regression line. And fortunately, our calculator will do this for us, but we're gonna just draw one by hand here, and then we'll learn how to do it on the calculator. So what you want to do as you put the ruler down is it doesn't have to go through any points. What you want to try to do is have the same number of points above and below the line. So, and it may or may not go through any actual points. So I'll try and draw this and see if it'll stay. It may or may not. But there's going to be roughly 4 or 5 above. You'll go through some of them perhaps. And we're just eyeballing it right now, but our calculator will be much more precise. Okay, so yeah, it likes to do that. I'll go and redraw that later. So we sketched a line. So what you could do is pick 2 points on the line and roughly try to find the line of best fit. But the problem is, what if you picked, if you couldn't see a visual of the data and see if you picked this point and this point, you would think there was a negative association and you would get a completely different line than if you picked, say, this point and this point. So you know how to pick 2 points if you know it's a line and find the equation. So we're going to skip that because we're going to let our calculators, we're going to learn how to do it on our calculators. And what the calculator will do is try and minimize the residuals, which we'll talk about in a second. But what we're going to do is use the calculator, and it will come up with what the regression equation is. So I'll tell you it's going to be y equals 12x minus 456. And these, on the calculator, you could get decimals. They don't have to be integers at all. And so then we can use this to predict, say, the temperature hits 100 degrees Fahrenheit. How many customers do we expect to have come in? So would we plug in 100 for X or for Y into the equation? Yeah, good, X, because X is the temperature. So then we would use it to predict. So you get Y equals 12 times X, which is 100, minus 456. So you can do that on your calculator. And we definitely want to give it units, but we would get about 744 customers. And so, okay. So any questions so far using the line of best fit to make predictions? Okay, now let's go on to something you probably have never heard of. It's called a residual, and we'll actually calculate one. So each data point has a residual, and what that is the vertical, okay, up and down, the vertical distance between the actual data point and the line of best fit. So I have to try to make my line stick a little better here to show you. We're going to calculate the residual for this point. So let me draw this in. So like a residual would look, say this point right here, this vertical distance is the residual. So if you could draw that in. In every point has a residual. So let me see test this. If the point is exactly on the line, like right here, what would this residual be? 0, right? So if the points are exactly on the line, the residual 0. Would the residual of this point be positive or negative? Negative, right? So the line of best fit, it's a model to predict, right? But it's not always 100% accurate, but it can get us close. So let's see the one at 63. That was the one we did. At 63 degrees Fahrenheit, what do you think, what is the residual approximately at 63? So what we can do is take the actual, and so you tell me what you think the actual is. Okay, good, 360. So the equation, you might want to highlight actually this equation is residual is actual y value minus predicted y value. And so you can take this actual was there were actually 360 customers, but what did our model tell us approximately? Does that look like, okay, the actual is a little lower on this line. So let's say, what does it look like here? So let's say 270. It's approximate, so that's fine. So we get how many customers? Okay, 90 customers. So what might be the implications if we had 90 more customers? If we use the model, but then we actually had 90 more customers, what might that mean for our business? Okay, it's doing better than we thought, right? Okay, so what your calculator will do for you is you're going to give it the data points in 2 lists, the X and Y values, and it will minimize the residuals. And that's how the calculator finds the line of best fit. It can't eyeball it like we did, but it'll minimize these residuals. Now, to see how well the line fits, there's something called the correlation coefficient. Correlation coefficient. And it tells us how well the line of best fit fits the data. So it's always a number between -1 and 1. And so you'll see, here's some examples. So if you get 1, your calculator will tell you what R is. And if you get a 1, then that means the points exactly fall on the line, every single one. If you get -1, then that's not and it's also a very good model. It just has a negative correlation instead of a positive correlation. If the line of best fit looks pretty horizontal, right? Same number of points above and below, there's absolutely no relationship there between X and Y. As X is increasing, we don't know what Y is going to be. So that's 0, and then you could have anything in between.